Hey, what's going on, guys? Let's do this problem right here. The question is asking determine whether the following series converge or diverge. So the first thing we are going to do is we are going to take the dominant terms in numerator and denominator and check whether it is converges or diverges, right? That's the first thing. So here we know that this 5 is dominant in top and 2n square is dominant in the bottom. So I'm going to take these two values and see whether it is converges or diverges. So let's take this one. Summation notation n is equal to 1 to infinity 5 over 2n square. You may already notice this one. This is a p-series. How to identify a p-series? If we have n power a number, this is p-series. If we have a number power n, that's geometric series. We have n power a number, so this is a p-series, and this can be also written as 5 over 2 sigma n is equal to 1 to infinity 1 over n square. And if you notice that power of this n is greater than 1, right? So whenever we have p series and the power is greater than 1, that always converges. So here this power is greater than 1, so we can conclude that this is a convergent p series, right? Convergent p series. But this is not the conclusion for this one, right? We just took the dominant terms and analyzed this one. But in order to find whether this one converge or diverge, we have to take the limit comparison test. So what we have to do is, if we take the limit, right, limit n approaches infinity, and take this part n over 2n square plus 3 and divide by this one, right? This is actually 5 over 2n square. So if I divide by this one, is same as if dividing 5 over 2n square is same as multiplying by 2n square over 5, right? And let's simplify this one. So 5 cancels, we are left with 2n square over 2n square plus 3. Limit n approaches infinity and 2n square over 2n square plus 3. So here the concept is, if you take the limit and if we get a positive finite number, that means this one, the denominator behaves, numerator behaves same as this one, denominator. So if we find this one, both of them find a positive finite number, both of them behave in the same way. So that's the concept. So let's see whether we get a positive finite number. And if you already notice, we have same power in the numerator and denominator, therefore we can take the first term as our limit. And if you take the first term, whenever we have same powers, we can take this one. And if you calculate this one, that's going to be the limit. This is 2 by 2, therefore the limit of this one is going to be 1. Or you can divide everything by the highest power, you will get the same answer, right? Since this is a positive finite number, this means if this one is convergent, this is also convergent, right? So we can conclude this is a convergent series. Let's look at the second example. Here we have sigma n is equal to 1 to infinity and n cube plus 1, and in the denominator we have n power 4 minus n plus 5. So let's look at the dominant terms. N cube is dominant term in the numerator and n power 4 is dominant term in the denominator. So let's take this one separately and see what we get. So here we are going to have n is equal to 1 to infinity n cube divided by n power 4. We can simplify this one. This is going to give us 1 over n. And if you notice, this is 1. And here we said if it's greater than 1, it converges. If it's equal or less than 1, if you have n power a number, and if this number is equal or less than 1, this one is a divergent p-series, right? If you notice, this is 1, so this is a divergent p-series. But this is not the conclusion. To find whether this one also diverges, we have to take the limit comparison test, and if we get a positive finite number, this means this also behave as this one. So we know this one diverges, and let's take the limit comparison to see whether we get a positive finite number, right? So let's go ahead and do it. So we have limit n approaches infinity, and the top term is n cube plus 1 over n power 4 minus n plus 5, and we are going to divide this one by this one. This is 1 over n. It is same as multiplying this one by n over 1, right? Dividing by 1 over n is same as multiplying this one by n over 1. And if we multiply this one, what are we going to get? We will get limit n approaches infinity, n power 4 plus n power 4 minus n plus 5, right? So this is what we get. And if you already notice, these two powers are same. Therefore, the value in front of this, if you calculate the value in front of this one, that's going to give us a limit. Here we have 1 over 1, right? So 1 over 1 gives us 1. So this is a positive finite number. So therefore, this one behaves as this one. So this one we already know this is divergent. Therefore, this one also divergent. And that's how we that's how we do the limits comparison test. I hope you guys find this video helpful. See you next time.